Okay, so the first part asks us to explain why a noise margin is between two gates, and it says that those gates can be the same or different gates. So, well, noise margin is defined as the amount of noise you can have on a circuit and still have the right answer. In order to fill this definition, there needs to be two circuits since one will be the input to the other circuit. The input gives us the upper and lower bound, the noise margin, depending if we're looking at the high or low margin, while the second circuit allows us to find how much noise we can have based on our input. When we talk about the same gates, we're assuming that there are two of the same circuits talking to each other. When we talk about two different ones, we assume one is the input to the other circuit. Yeah. Okay. So on to the next one. What is noise margin low and noise margin high for the two cascaded identical inverters for the supply voltage of 6 volts and the following VTC? So noise margin high. Oh, sorry. Noise margin high can be defined as V max from the input circuit minus V input high found from the second circuit, and then similarly noise margin low can be defined as the V input low from the second circuit minus V minimum from the first circuit. Um, and we can find V min by looking at this, or sorry, V max to is the max voltage the input circuit can output. And so in this case, we're going to be looking at around 6 volts since that's a steady state. And in order to find Vmin, similarly, we can, this is just the minimum voltage the input circuit can input, which is 0.5 volts. Okay, and then we can just write that down. 6 volts, Vmin equals 0.5 volts. Um, Now we move on to the other parts of the equation we have to find. We can find V input low by looking at the output circuit and where the slope is about -1 and it's touching where the output is low. So we're going to be looking at this part. We can just estimate that it's around here where M is equal to -1, and we can just go straight down and we can see that V input low is about 2.25. And in order to find V input high, similarly, we can find where the slope is also -1. And it's also touching the input high area. So right here, and then we can just say that's about 3 volts input high. And now that we have all the parts of the equations, we can just plug it into the equation. Is 6 minus 3 equals 3 volts for the noise margin high. And for the noise margin low, we can do that as well. 2.25 minus 0.5 is equal to 1.75 volts. Yep. All right. All right. So for the next part is asking for what is VM or the switching threshold. Well, we can find the switching threshold, or that's where Vin is equal to V out. So we can just simply draw a slope of 1 since that's where Vn is equal to V out. So let's go ahead and do that. Let's try to do 5 volts. I think right there. Yep, 5 volts. Okay, and then where this line crosses the VTC is where VM is. So let's just do here, and we can just dot it down, and that's about 2.7 2.72 ish. So let's just do that. And yeah, I think that's it.